Let's learn the introduction to artificial intelligence today. Welcome back to Artificial Intelligence Introduction class. In this session, we've learned the compose of computer vision. And in this class, we've learned 3 typical applications in computer vision. Let's move on to the first part. Image classification is like sorting pictures into different groups. We can use machine learning to train a computer program to look at pictures and automatically figure out what groups they belong to. This involves steps like collecting pictures, picking out important features, training the model, testing how well it works, and then using it to sort new pictures. We might use this in things like image search or security cameras. The traditional process of image classification usually involves several steps, including collecting and preparing data, extracting features, selecting and reducing features, training classifiers, evaluating and tuning models, and deploying models for predictions. In this process, we need to manually choose or design appropriate feature extraction algorithms and train classifiers to achieve better classification performance. However, this method requires a lot of time and effort, and may be limited in some complex image classification tasks. Therefore, nowadays, most image classification tasks use deep learning method to automatically measure features and classifiers from raw images, which can achieve better performance. Deep learning-based image classification algorithms use deep neural networks to automatically learn features and classifiers from raw images. Commonly used deep learning models include convolutional neural networks, recurrent neural networks, residual networks, and attention networks. These models can automatically learn features and clusters through a large amount of training data and aggregation algorithms, thereby achieving high precision image classification. Unlike traditional methods, deep learning methods do not require manually designed feature extraction algorithms, making them more adaptable to different image classification tasks. In practical applications, deep learning-based image classification algorithms have been widely used in fields like image search, intelligent monitoring, autonomous driving, and medical image analysis. Now we move on to object detection. Object detection is an important task in field of computer vision. Its purpose is to automatically detect objects containing images or videos and provide their positions and category information. Unlike image classification, object detections need to identify and locate multiple objects in the image. You can see in the chart, these are deep learning algorithms used for object detection. Each of them have different characteristics and pros and cons, such as different performance in terms of speed, accuracies, complexities, and so on. For example, the YOLO series algorithms perform well in terms of speed, while the MASC-R CNN can detect and segment target object at the same time, depending on the application scenarios and specific requirements. One can choose the appropriate algorithms that suit their needs. And now let's have a look at the image segmentation. Image segmentation is a method of dividing an image into several regions with different characteristics, with each region considered a meaningful part of the image. And it has wide applications in computer visions, medical images, autonomous driving, robotics, and other fields. The goal of image segmentation algorithms is to extract the interest parts of the image from complex images and distinguish them from the backgrounds. Traditional image segmentation algorithms include threshold segmentation, edge detection, region growing, and so on. While the emergence of deep learning techniques has also brought new ideas and methods for image segmentation, such as semantic segmentation, instance segmentation, and panoptic segmentation, the table compares different types of image segmentation algorithms, including threshold-based, age-based, region-based, and neural network-based methods. Threshold-based algorithms applied a fixed threshold to pixel intensities to segment images, making them simple and fast, but only suitable for images with high contrast and simple backgrounds. Edge-based algorithms detect edges in the image and group them into regions, making them robust to noise and image qualities variations, but sensitive to edge detection algorithms and parameters. Region-based algorithms divide the images into regions based on similarity criteria such as color, texture, intensity, making them able to handle complex images but computationally intensive and sensitive to initial conditions. Neural network-based algorithms utilize deep learning models such as U-Net, FCN, and SigNet to segment images, providing high accuracies and handling complex images but requiring large amounts of training data and being computationally intensive. It's important to note that advantages and disadvantages mentioned are not exhaustive and may vary depending on specific implementations and applications. That's all of today's lesson. And in this class, we will learn the lateral language processing.